My dear viewers, now discuss MCQ question answer P block element group 17 based on ISC class 12. Okay, now group 17 elements, that is also known as halogen, okay, are highly reactive nonmetals that include fluorine, that is F, chlorine, that is Cl, bromine, that is Br, iodine, that is I, and astatine, that is At. Follow the pattern 8, 18, 18, 32. Find out the atomic number in group 17. Now, atomic number of fluorine 9. 9 plus 8, that is 17. Atomic number of chlorine 17. Atomic number of chlorine 17 plus 18. Atomic number of bromine 35. 35 plus 18. Atomic number of iodine 53. 53 plus 32. Atomic number of astatine 85. Okay, now discuss the very important MCQ based on ICSE class 12 in P block group 17. Okay. Question number 1. Group 17 elements are also called halogen. This statement is true. Due to explain, group 17 elements are called halogens. Name halogen, that is Greek language for halo means sea salt and gens means producing, that is means sea salt. Okay, next question number 2. Which of the following element is most reactive? Option B, that is fluorine. Due to explain, of all the halogens, fluorine is the most reactive and hence is also called superhalogen. Fluorine is also the most electronegativity, that is the value of electronegativity 4 element in the periodic table. This indicates that fluorine has a high tendency to gain electrons from other elements with lower electronegativities. Next question number 3. Which of the following halogen is radioactive? That is option C, astatine. Okay, due to explain for this part, astatine, that is atomic number 85 and symbol 80, is radioactive and hence occurs in nature only in tracks. Okay, therefore not much is known about its chemistry, though it might be expected to be metalloid, that is the property so middle point, that is metal, and non-metal, that is metalloid. Next question. Halogens do not occur in the free state. This statement always true. Due to explain for this part, halogens are highly reactive elements and hence do not occur in the free state. They mainly occur in the combined state in the form of their halides salt. Okay, although iodine also occur as iodate, that is IO3 minus. Next question number 5. Which of the following is not a mineral of fluorine? This statement is proper answer option D, granite. Okay, due to explain for this part, fluorine occurs as insoluble fluoride to be extent of 0.05 in the earth crust. The chief minerals of fluorine are fluorspar, formula CaF2, and cryolites, that is formula Na2Al F. Question number 6. What is the general electronic configuration of halogen? Okay. Option A, Ns2Np5. Due to explain for this part, the elements of the group 17 have 7 electrons in the valence shell, and hence their general electronic configuration Ns2Np5, that is Ns2Npx2 Npy2 Npz1, where N equal to 2 to 6. Thus, they contain 1 electron less than the nearest inert gas configuration. Okay, next question, question number 7. What is the correct order of enthalpy of dissociation of halogen? Option B, that is chlorine greater than bromine greater than fluorine greater than iodine. Due to explain for this part, enthalpy of dissociation decreases as the bond distance increases from fluorine to iodine due to corresponding increase in the size of the atom. As you move down the group from fluorine to iodine, the fluorine-fluorine bond dissociation enthalpy is, however, smaller than that of chlorine-chlorine and even smaller than that of bromine-bromine bond. Okay, this is due to the reason that fluorine atom is very small. Hence, the electron repulsions between the lone pairs of electron are very large. Okay, next question, question number 8. What is the atomicity of halogen? That is option B, that is diatomic. Okay, each halogen has 1 electron less than that of the nearest inert gas. As a result, halogens are very reactive elements. They readily share their single unpaired electron with other atoms to form covalent bonds. Okay, thus all the halogen exist as diatomic molecule. That is example of fluorine F2, chlorine F2, bromine Br2, iodine I2. Okay. Next question, question number 9. How many types of inert halogen? Option 4. Due to explain for this part, 4 types of inert halogen compound, that is diatomic, tetratomic, hexatomic, and octatomic. Due to explain for this example, that is diatomic, CLF, BRF, ICL, and IBR. Tetratomic interhalogens example for the part, that is ClF3, BrF3, and IF3. Hexatomic interhalogens, that is example BrF5 and IF5. Okay, clear? Next question, question number 10. Which of the following halogen exists as a solid at room temperature? Option B, fluorine. Due to explain for this part, the strength of the van der Waal between molecule force increases as the size of the halogen increases from fluorine to iodine. Okay, as a result, fluorine and chlorine are gases at room temperature. Bromine is liquid, whereas iodine is a solid. Okay, next question, question number 11. Why does fluorine form only one oxo acid? That is option A, highly electronegativity of fluorine. Due to explain for this part, fluorine is the most electronegative element on the periodic table. Due to its high electronegativity and small atomic radius, fluorine only form one oxo acid, that is HOF, known as hypofluorous acid. Okay, next question, question number 12. All the halogens form only one oxo acid due to their high electronegativity and small size. This statement false. Okay, due to explain for this part, only fluorine form one oxo acid due to their high electronegativity and small size, and the other halogens form several oxo acids. Most of them cannot be isolated in pure state. Okay, they are soluble only in aqueous solution or in the form of their salt. Okay, next question, question number 13. Which of the following is not an oxo acid of chlorine? Explain for this part. Answer A, HCl, that is absence of oxygen. Okay, due to explain for this part, HCl, known as hydrochloric acid, it is not an oxo acid. All oxo acid have a acidic hydrogen bound to an oxygen atom. In HCl, the hydrogen is bound to the chlorine atom, making it Lewis acid. Next question, question number 14. Which of the following is a hypohalous acid? That is option C, HOF. Okay, due to explain for this part, HOF, hypohalous acids, are oxo acid in which the hydroxyl group is singly bonded to hydrogen. In HOF, the hydroxyl group is singly bonded to fluorine, making it a hypohalous acid named hypofluorous acid. Okay, next question, question number 15. What is bond angle of hypochlorous acid? That is option D, 109.5 degree. Due to explain for this part, hypochlorous acid is an oxo acid of chlorine in which the hydrogen atom is singly bonded to the hydrogen atom, and chlorine is also singly bonded to oxygen atom, forming a bent structure with bond angle 109.5 degree. Okay, next question, question number 16. How many bonds does chlorine make with oxygen in perchloric acid? Okay. Option A, that is 3 double bond and a single bond. Okay, due to explain for this part, the formula of perchloric acid is HOClO3. Okay, in which the chlorine group is, it is to 3 oxygen atom, okay, and 1 hydroxyl groups. The 3 oxygen atoms are attached to chlorine through a double bond and the hydroxyl group is single bond to chlorine. Thus, there are 3 double bonds and single bonds between oxygen and chlorine. Next question, question number 17. Which of the following show the correct sequence of acidic strength? Okay, that is option A, HClO4, A is BrO4, and A is IO4. Due to explain for this part, as the electronegativity of the hydrogen decreases, as the tendency of the XO3 group to withdraw electrons of the OH, that is oxygen hydrogen bond, towards itself decreases, and hence the acidic strength of the parhydrolic acid decreases in the same order. Hence, the acid strength of perhalic acid decreases in the same order. Okay. Next question, question number 18. Which of the following is the correct order of oxidizing power of perhalate? That is option D, that is BrO4 bond greater than IO4 greater than ClO4. That is the negative charge. Okay, anion form. Okay, due to explain for this part, halides are strong oxidizing agents. Their oxidizing power decreases in order BrO4 minus greater than IO4 minus greater than ClO4 minus. Thus, this can be explained on the basis of their electrode potential. Okay, although among the perhalates, BrO4 is the strongest oxidizing agent, yet the weaker oxidizing agent than F2. Next question, question number 19. Which of the following is the correct order of acidic strength? Option C. The correct order HClO4 greater than HClO3 greater than HClO2, due to explain the another way for the oxidation number. Okay. Now the explain for this part, acidic strength of oxoacid of the same hydrogen increases with increase in the oxidation number of the hydrogen. The oxidation number of hydrogen in HClO4, HClO3 and HClO2 is 7, 5 and 3. So, the acidic strength of HClO4 is the greatest following of the HClO4 and HClO2. Okay. Next question, that is the question number 20. The acidic strength of HClO4 is lesser than that of HClO. This statement is true. Okay. Not. It is statement is always false. Okay. That is the not lesser. That is greater than. HClO4 greater than HClO. So the statement always false. Okay. Due to explain for this part, acidic strength of oxoacid of the same hydrogen can be determined by the oxidation number of the halogen in the compound. In the HClO4, the oxidation number of the chlorine is +7 and HClO of the oxygen number chlorine +1. So the acidic strength of HClO4 is greater than that of HClO. Okay, my dear viewers, next question, that is the group 17 other MCQ most important question. Please show the next part. Thank you, my dear viewers. Thank you.